Hello everybody, this is Samuel instructor and I just received few questions based on the mock test we did, so I thought I'll make a quick video and explain it to you guys. I'll just go through all the questions and let's see if it makes sense or not. Question first is simple displacement question. Earth grader is going 350 meters north, so that's the first dimension. Then it's going 275 west. So what distance would it travel if it could go directly? That would be the resultant. You can simply use Pythagoras theorem and it's under root of 350 square plus 275 square. I don't think this should be a problem. Let's look at the vectors addition again. Okay, I know we did a lot of practice. We did a lab. Maybe we forgot by this time. So let's give it a refresher. A ship travels 50 miles on a course 15 degrees south of east. So I'll start drawing my vector 15 degrees south of east, 50 miles. Okay. As soon as I draw it, I have to make sure I put my y component on it. Just throw a vertical line and that's your y component. This will be your x component. So if I am given hypotenuse, I'm given an angle 15 degree. Can I find my x component, y component? Yes, I can. Using trigonometry ratio, 50 cos 15 is 48.3 miles. That would be my x component, the horizontal one. And you can see it's positive because I'm on positive x-axis. Then 50 sine 15. Sine is opposite upon hypotenuse, right? So sine 15 is opposite, which is y component upon hypotenuse 50. So y component is 50 sine 15 degrees, which is negative 12.9 miles. This is a negative sign. It went up, but that means it's on a negative y-axis. It is going below the zero level of y-axis. Okay, so next thing. What's the next direction? It says then it travels 85.5 miles on the course 60 degrees west of south. Okay, so just draw a new one and say, okay, if you don't even have to draw it together. It's good when you draw it together for the sake of angle. Even that you can find out without that. We did some simulation exercises and you saw that you can put one thing at a time and another thing after some time. Still you can add up the resultant. So let's see this one. If I draw my axis here and I say, okay, 60 degrees. So the angle was 60 degree west of south. So 60 degree west of south. So that's my angle right here, 60 degree, and it's going this way and it's 85.5 mile. As soon as I draw my vector, I have to throw a perpendicular on it. Okay, this time it is going to be a horizontal one parallel to x-axis. As soon as I draw that, I have this angle 60 degree. I have a hypotenuse 85.5. This is a right triangle because I just made a perpendicular on it. What did I get? I got my y component and x component. Does it make sense, right? So my x component is going to be opposite upon hypotenuse. Opposite of 60, which is this, upon hypotenuse. So 85.5 sine 60 is equal to 74. So my x component will be 74, which is negative again. So this is my negative sign. Sorry, it went up there. And finally, my y component right here is going to be 85.5 cos 60 degree, which is negative 55.5. What do I do with the resultant? I will simply add the x components of this a and b. I'll add y components of a and b, and I got my resultant, x and y component, right? We have done this exercise twice. Once we did it in simulation activity. Second time I gave you a handout and you added all the x and y components and you just found the resultant. If you don't remember, just take it as a refresher, go back to the Brightspace and check out all the simulation exercises and all the activities that we have done. Again, what is the resultant? Resultant will be, so this is the resultant. If I'm using my tail to head method, head to tail method, then this will be my final resultant, right? This was my A vector, this was my B vector, so my resultant vector would be right here. Okay, fair enough. So how will I find my resultant vector? I'm given its x component, which is right here, and its y component, which is right here. If I have its x and y component already, which I found out, then what would be my resultant? Just by using Pythagoras theorem, under root of perpendicular square plus base square is equal to 61.2 miles. So my resultant came to be 61.2 miles. Okay, now last thing, I cannot just say a vector with its magnitude, I have to give the direction as well. So I'll say, okay, let's assume this angle here is alpha. So if this is alpha, then what is tan alpha? Tan alpha will be opposite upon adjacent. Opposite will be the y component, adjacent will be the x component. Is that okay? Then what is the angle alpha? It's tan inverse of opposite upon adjacent. That will be 65.2 degree. So this is how I write my answer. The resultant displacement from its starting position point to its ending point is 61.2 miles at 65.2 degrees south of west. Okay, hope that helps. Third question is, car is traveling along a road. Its velocity is recorded as a function of time in the graph below. So it is pretty easy here. All the choices are so easy to make that only A will be the correct option. Just let's see. This is a velocity and this is time. I can see the velocity is 15 meter per second from here all the way till here, that is until time t is equal to 3 seconds. So the body or car is moving at a constant velocity for the first 3 seconds. That means there has to be a constant change in motion. What is velocity? That is slope of the position time graph. So the slope of position time graph is going to be a constant 15 meter per second, or whatever that quantity was, 15 meter per second. So you'll see a constant slope. Do you see a constant slope anywhere else? No, this starts with a plateau. What does this straight line means? If the position is at straight line, say this was, assuming this was 5 meters. If it's still at 5 meters, that means the body stopped. That means there is no velocity. This case, it is at 0 and it does not change. 0, no velocity, the body is stationary. Stationary. By looking at just this point, I can say that, okay, this is going to be my graph. This is the graph which expresses the constant velocity from this point to this point. Okay, let's see from there. You will see now the velocity is decreasing rapidly all the way to 0. Okay, you will see that decrease in velocity with this curve. We have not covered the curves in this part of the chapter, so let's carry on and see that at time t is equal to 8 seconds to time t is equal to 13 seconds, there is a 0 velocity. That means there should not be any motion. That means the position should be constant. So say this was 15 meters, the body should be at 15 meters for all that time. And it makes sense, right? 8 to 13, and here arbitrarily that 8, arbitrarily that's 13, so that makes sense. And finally the body started moving again, so the velocity is increasing consistently from 13 seconds to 16 seconds. So this change in velocity is actually represented as a curve on the position time graph, which we did not cover in this chapter. But yes, we did cover that at 20 seconds, if you see a constant velocity, then you will see a slope in the graph. And that proves that A is my correct answer. And just write a little quick few lines. I have given some detail, but you don't have to write everything. That's how you will represent this answer. Draw the velocity time versus time graph for an object whose motion produced the position versus time graph shown below, and adjust the legends if you want. I'm not adjusting any legends. I can simply see this is position, this is time at for 1 meter in 1 second. The body covered 2 meters in 2 seconds. Body covered 3 meters in 3 seconds. What's my velocity? It is going to be 1 meter per second, and boom, that will be a straight line. Slope of the position time graph is actually the velocity, right? In second scenario, easy. First, the body was moving at 1 meter per second velocity. See, change in velocity. So I know you are thinking, oh, it's starting from 2 meters. What should I do? You don't have to do anything. Velocity is change in position divided by time. Change in position in 1 second. The body final position is 3 meters. Initial position is 2. 3 minus 2 is 1. 1 divided by 1, 1. That's gonna be its velocity up till this point. So 1 meter per second, 1 meter per second. But at this point, the body is going backwards. It's going reverse. From 4 meters, it started going backwards to 0 meters. So if the body's direction is reversed, velocity direction will be reversed as well. It's a vector, right? So let's see. Now when it's going back from 2 seconds to 3 seconds, which is 1 second, 3 minus 2 is 1 second, the body changed its position from negative from 2 minus 4, which is negative 2. So the velocity will be negative 2 divided by 1, which is negative 2 meter per second. So your body will, after 2 seconds, your body will start at a velocity of negative 2 meter per second, and it is changing until t is equal to 4. T is equal to 4, as simple as that. Okay. Let's look at this question. At the end of a race, a runner deaccelerates from velocity 9 meter per second at rate of 2 meter per second square. How far does she travel? In next 5 seconds, time is given, initial velocity is given, final velocity we don't care. We have acceleration, which is deceleration. So s is equal to ut plus half at square. We are given time, initial velocity, acceleration will be negative because it's deceleration. So substitute and you will get 20 meters. Second part is second part is what is her velocity? What is her final velocity? And that will be v is equal to u plus at. Then substitute and you will get your final velocity is negative 1 meter per second. Does it make sense? Is that runner running in the backward direction? No, it does not make sense. That's what you want to know. Like, does it make sense to you? Is that a fair answer? Can somebody's velocity can be final negative 1 meter per second? Yes, in some cases it will be. We just saw the car had a negative velocity. But in this case, it is runner, it's running. It cannot just keep running and then going back. So that does not make sense. Lastly, calculate height of the cliff if it takes 2.35. So this question, I know I threw it on the test thinking some other question. My bad, my apologies. This one will be beyond the topic, but I can explain you in the class. Question 7 is pretty straightforward. An object is dropped from this height. Determine the distance traveled during the first second. So if it says first second, that means t is equal to 1. So use the equation, substitute t is equal to 1, and you got your answer. Determine the final velocity when it hits the ground. It's hitting the ground. That means it's covered the complete distance, which is 75 meters. V square is equal to u square plus 2as, and finally answer. Okay. Third part, once again, this will not be covered. This is not valid. My mistake. I should not have put it there. I just threw some questions for mock, so I make those mistakes all the time anyways. But hope this helps. If you have any questions, send me an email or post it in the discussion board. Thank you.